A system defines a binary classification rule. An applicant either passes or fails based on crossing a fixed cutoff. The rule does not reward distance above the threshold. It only rewards being on the correct side of it. Once the cutoff becomes visible, effort reallocates toward crossing the line. Improving beyond the threshold carries no additional return. The incentive compresses effort toward the boundary instead of spreading it across the full range. Performance begins to cluster near the minimum required level. The observable outcome looks like declining average quality above the threshold. A common explanation attributes this to declining capability or effort. It appears as if participants are simply not trying to excel. But this interpretation treats behavior as independent of the rule. The system does not reward excellence once eligibility is secured. It only differentiates between pass and fail. Rational actors shift from maximizing performance to minimizing risk of falling below the cutoff. The optimization target becomes positional, not absolute. A micro-decision emerges at the boundary. Applicants choose to allocate marginal effort only where it increases the probability of crossing. Effort applied beyond that point produces no marginal benefit. The system begins to favor threshold-focused adjustments. This produces edge compression. Outcomes concentrate tightly around the cutoff instead of distributing across a spectrum. The variance above the threshold collapses. The boundary becomes the dominant reference point for behavior. What appears as underperformance is actually alignment with the reward structure. Exceeding the threshold does not change classification. Remaining just above it secures the same outcome as far above it. The system equalizes outcomes while compressing effort. As more actors adapt, the density near the cutoff increases. Competition shifts from overall performance to boundary positioning. Small differences near the threshold determine classification outcomes. The system becomes sensitive to marginal adjustments at the edge. Coordination begins to emerge implicitly. Participants monitor where the boundary lies and how others cluster around it. Strategic behavior converges on optimizing just enough to cross. The boundary becomes a shared focal point. The system starts filling with borderline cases. Many outcomes lie just above the threshold. Few outcomes extend significantly beyond it. The distribution reshapes around the cutoff. This is not caused by a decline in capability. It is caused by a redefinition of what is worth optimizing. The incentive removes the gradient above the threshold. The system flattens performance beyond the cutoff. A measurable distortion appears. The gap between threshold-level performance and high-level performance narrows. The classification system masks underlying differences. Outcomes appear uniform despite hidden variation. Attempts to interpret the system through average performance miss the mechanism. The average reflects clustered behavior, not independent decline. The boundary drives convergence. The signal no longer reflects true capability distribution. Once the system is populated with borderline cases, risk increases. Small fluctuations can push outcomes below the threshold. Actors respond by tightening focus on boundary maintenance. Behavior becomes defensive rather than expansive. The cost of falling below the threshold outweighs gains above it. This asymmetry reinforces clustering. Participants avoid downside rather than pursue upside. The system stabilizes around minimal compliance, and the boundary becomes more influential than the rule itself. Actors do not optimize for the full objective, they optimize for threshold positioning. And the cutoff governs behavior more than the underlying criteria. Even if the threshold remains fixed, its behavioral impact intensifies. As density increases, competition near the edge becomes more precise. Marginal gains near the boundary dominate strategic choices. The system amplifies sensitivity to small changes. Over time, the system's composition changes. It contains a high proportion of borderline cases. Extreme high-performance outcomes become rare. The distribution reflects incentive alignment, not capability. The classification rule continues to function as designed. It separates pass from fail, but it also reshapes how effort is allocated across the system. The outcome is a stable equilibrium centered on the boundary. At equilibrium, behavior no longer aims to maximize performance. It aims to secure position relative to the cutoff. The system becomes organized around a single dividing line. All adaptation orbits that threshold. The system stabilizes with compressed outcomes. Borderline positioning becomes the dominant strategy. Variation above the threshold remains suppressed. The equilibrium persists as long as the binary rule remains unchanged. As the boundary becomes the dominant reference, time horizons begin to compress. Effort is allocated only to immediate threshold crossing rather than long-term capability building. Short-term positioning replaces cumulative improvement. The system shifts toward repeated short-cycle optimization around the cutoff. Because classification depends on a single crossing point, information about the exact location of the threshold becomes disproportionately valuable. Applicants begin to infer, estimate, and track where the boundary lies. Small informational advantages translate into higher probability of crossing. The system starts rewarding boundary awareness over absolute performance. This creates a symmetry between those who can better detect the cutoff and those who cannot. Behavior diverges not by capability, but by precision in positioning relative to the threshold. The distribution tightens unevenly around the boundary. The system amplifies differences in positional knowledge rather than output quality. As clustering intensifies, the threshold itself becomes more volatile in effect. Minor fluctuations in evaluation or measurement produce larger shifts in outcomes. The same performance can oscillate between pass and fail. The system becomes increasingly sensitive to marginal deviations. In response, actors tighten their margin of safety above the cutoff. They no longer aim to just cross, but to remain narrowly above it. This slightly expands the cluster but maintains compression near the boundary. The system reinforces a narrow band of acceptable outcomes. What initially looked like a stable threshold begins to generate cyclical adjustments. Increased density near the cutoff raises competition within the same narrow range. Each participant's adjustment alters the effective position of others. The boundary becomes a zone of continuous micro-adjustment. This produces a feedback loop where local positioning decisions propagate across the entire applicant pool. Each shift in clustering changes the competitive landscape at the edge. Participants recalibrate in response to others doing the same. The system becomes self-referential around the threshold. As this loop repeats, the cost of deviation from the boundary increases. Moving too far above wastes effort. Falling below carries immediate penalty. The acceptable strategy space narrows tightly around the cutoff. Over time, the system begins to suppress signals that are not directly tied to threshold crossing. Indicators of broader capability lose relevance if they do not affect classification. Only signals that move an applicant across the boundary retain value. The measurement system collapses into a single dominant dimension. This creates a distortion where the observable signal reflects boundary optimization rather than true distribution. External observers interpret the compressed outcomes as homogeneity, but the system has not equalized capability. It has equalized behavior around the cutoff. As scaling continues, the proportion of borderline cases increases further. The system's composition becomes dominated by outcomes that are nearly indistinguishable from the threshold. Extreme values become statistically rare within the accepted pool. The system normalizes proximity to the cutoff. At this stage, small structural changes in the threshold produce amplified effects. A minor shift in cutoff position reclassifies a large portion of participants. The system becomes highly reactive to boundary adjustments. Stability depends on maintaining the exact location of the threshold. However, the threshold itself was never designed to manage this density. It was designed to separate outcomes, not to regulate clustered behavior. The mechanism now operates under conditions it did not anticipate. The system stabilizes despite this mismatch. There is an analytical tension here. The rule continues to function in separating pass from fail, but it no longer differentiates within the passing group. The classification remains intact, yet its informational content deteriorates. The system both works and loses resolution at the same time. With repeated cycles, the boundary effectively replaces the broader objective of the system. Participants no longer interpret the rule as a standard of performance. They interpret it as a positional game around a line. The system's purpose becomes secondary to its threshold. This reinforces the feedback loop further. Every iteration strengthens the incentive to remain near the cutoff. Every adjustment by one participant tightens constraints for others. The system converges toward maximum density at the boundary. Eventually, the equilibrium becomes rigid. Behavior stabilizes around maintaining position relative to the threshold. Deviations are quickly corrected through adaptive responses. The system locks into a narrow behavioral band. At this point, scaling no longer introduces new variation. It only increases the density of similar outcomes near the boundary. The mechanism reproduces the same pattern at larger volume. The equilibrium persists as a function of the threshold structure. Before the threshold dominated behavior, the system implicitly rewarded distance above the standard. Higher performance created differentiation and effort distributed across a wider range of outcomes. Once the binary cutoff became the decisive rule, that gradient disappeared and effort narrowed toward crossing. The system now rewards precise positioning just above the boundary. Performance beyond that point produces no additional return, so it is systematically ignored. Falling below the threshold remains fully penalized, tightening behavior into a narrow band of minimal compliance. What is measured shifts from how far above the standard one performs to whether the boundary is crossed at all. Signals that do not influence classification lose functional value. Only movements that change position relative to the cutoff remain relevant to decision making. As a result, the stable pattern becomes predictable. Actors allocate effort to secure and maintain threshold position rather than expand capability. The system consistently reproduces clustered outcomes centered around the boundary. In this equilibrium, variation above the cutoff is suppressed, while sensitivity below it remains high. The rule continues to separate pass from fail, but it no longer distinguishes within the passing group. Behavior reorganizes around the cutoff because the incentive structure no longer rewards anything beyond it,